Okay, good morning, class. Okay, today we will look at the last chapter. Okay, last chapter. Normally, yeah, this is the last one. Vector value functions, and this one actually takes around 3 weeks. It covers 3 weeks. The syllabus is covered for a duration of 3 weeks time. Sorry, my sound is still not not properly recovered since last week. Okay, this one, vector value function, we will look at the differentiation first. Okay, normally, final exam, it will there's one question come from this vector value functions, this chapter. Okay, so upon completion of this lesson, you should be able to compute operations. There are a number of operations of vector value functions. And today we will look at how to differentiate these vector value functions, okay, and also the basic operations. Okay, what is the vector value function first? Okay, vector value function is denoted by R. Okay, this R, it looks like this is bold. Okay, this is bold. So when we write R, we will give a symbol underneath to represent this is not R, this is a vector. Okay, this is a vector. Because you see this one, R in T. So you have this component of I, J, and K. Okay, these are the component functions, F, G, and H. They are all in T, okay, in parametric form. In parametric form. So the domain, that means the input. The input of these functions are a set of real numbers, and the range is a set of vectors. Okay, so the input will be this T. Okay, T is a set of real numbers, and the output is a vector. Okay, this is a vector. So when you write the R, you can write either this. Normally we use this one. Okay, normally we use the R bar, and then we have FT I. Okay, the IJK, we use this one. I, J, F, G, H, K. Okay, this is the vector. Okay, R and T. R and T. And F, G, H are the scalar functions. Okay, so scalar functions, and the name is called component functions of R. Okay, so a vector value function is actually a vector function that indicates the position of a moving particle. Okay. So from here, actually, we know what is the position at a specific time. T represents the time. For example, this one, when we throw a ball and the ball, let's say, not a ball, a moving particle. Let's say a moving particle, it moves from this point. When T equals to 0, it's here. T equals to 1, 2, 3, and so on. And let's say the moving particle moves in this direction. And at a specific time, we can know the position of the particle, of the moving particle. So when T equals to 0, this is your R0. Okay, R0, that means the position of the moving particle is R0. Okay, when T is 0. When T is 1, the position is R1. Okay, this is R1, R2. So this one, we display this in 3D, okay, 3-dimensional. That's why we have F, G, and H component functions. Okay, so now let's say we have two vector functions, F and G. Okay, F and G. So the vector sum, we can sum up two vectors, okay, just by summing up the component function from the same, this IJK. So x1 plus x2 under I. y1 plus y2 is a component function of J. z1 plus z2 is the component function of K. Okay, this is vector sum. And the product of a scalar valued function and a vector valued function. This is a scalar valued function. Okay, a scalar function. This is a vector valued function. Okay, this is a vector. So when a scalar function multiply to a vector function, that means the scalar function will be multiplied to every single component function. Okay. Okay, for example, if you have, let's say t squared, and your f, let's say your f function is 2ti plus pj plus t squared k. Okay, let's say this is your f. So when we have a scalar function multiplied to a vector function, it means that t squared will be multiplied into every single component function. Okay, so you have a 2t cubed I plus t cubed j and p to the power of 4 k. Okay, this is how we multiply a scalar function to a vector valued function. That means this one will be multiplied into every single component functions. Okay, and okay, this one, the third one, dot product. Okay, dot product. That means we are using the first component. Okay, f. The first component multiplied to the first component from f and g. Okay, f dot g. So x1 dot x2, not dot, x1 times x2, y1 times y2, z1 times z2, and we sum up all of this. So the dot product, the output is not a vector. This is not a vector because you don't see anymore the ijk here. This is all scalar functions. Okay, so just use x1. X1 times x2 plus y1 plus y2 plus z1 times z2. No more ijk because the product function of the dot product, okay, the dot product produce scalar function. Okay, the dot product produce scalar function. Okay, and one more product is called cross product. Okay, cross product, it produce vector. Okay, that's the difference between the dot and cross product. Cross product produce vector. So you see this output is a vector. Okay, so for the cross product, this one cross means that f is x1, y1, z1. Okay, the g is x2, y2, z2. So you have to follow the sequence. Okay, and at the top, this is ijk. So this one, you just use the way that you compute for determinant to find for the answer. Okay, this one. Okay, we will start from this direction first. So this is y1, z2, I. Okay, y1, z2, I. And this, with this, you have x2, z1, j. Okay, x2, z1, j is a plus. Right, it's a plus. And last one, this two with k. So x1, y2, k. x1, y2, k. And minus the other direction. Okay, minus the other direction, x2, y1, k. This one minus x2, y1, k. Okay, this two, y2, z1, I. Okay, minus y2, z1, I. And the last one, this one, x1, z2, j. Okay, so it's minus x1, z2, j. So means that you just use the three in a group in starting from this direction minus the other direction. Okay, same as how you find for the determinant. Then you combine the component functions of I, j, and k. Okay, and last one, magnitude. Okay, magnitude, we use double line. This one, double line. Magnitude, it means the magnitude of the vector. So we square each of these component functions, and sum them up in a square root. Okay, this one, this one is, you will use this when we compute for the magnitude. Okay, this one is a scalar function multiplied to a vector value function. So we can write in this form. Okay, for scalar function, you just put this, a modulus, and for the vector function, we still need to find for the magnitude. Okay, because scalar function, scalar is not a vector. Okay, this one, we just put a magnitude. This one, we will look at the example later. Okay. Okay, the first example, given f and g. We want to compute ET times FT and then plus 2 times GT. So meaning that this ET will be multiplied to every single component. Okay. There is different way to present a vector. You can either write in this way, I, J, K, or you just take the component function and display in this bracket. Okay, this bracket. So the first component is E negative 2t. Okay, E negative 2t. And the second component function is negative E3t. Okay, and the last component function is negative t. Okay, you can either display the vector value function in this form or this form. So now we want to multiply the ET to this FT. Okay, this is our FT. So ET. So ET multiplied to every single component function. So this one we have negative t. Okay, t minus 2t, we have negative t. T plus 3t, we have 4t. And this one times this, you get this. Okay, so 2 times gt, 2 multiplied to every single component function from here, 1, 2, 3. Okay, take together the negative sign. Okay, 2 multiply into every single component, you get this. Then finally, you sum up. When we sum up, that means the component function of I plus component function of I. Okay, the component function of J plus component function of J. Okay, and same goes to the last one, component function of K. Okay, so these are basics. Okay, very simple basics. So far, any questions? Okay, we look at this one, magnitude. This is a scalar function, and this is a vector function. Okay, so now we want to compute for the magnitude of the product function for these two. Okay, so according to the formula just now, we have this one equals to this. So for the scalar function, this one scalar function, you just put a modulus. The modulus of t plus 1 is t plus 1. And the magnitude of the vector function, okay, this is your vector function, sine t, cos t, and 1. Okay, to find for the magnitude, you square each of this component function, you sum them up in the square root. Okay, so sine square t plus cos square t is 1. So 1 plus 1, you get a cert 2. Okay, cert 2 times this. Magnitude, the output of the magnitude is not a vector. Okay, the output, this one, this is the output of the magnitude. This is not a vector, this is a scalar function. Okay. Okay, any question for this one? Okay, another function. We have this scalar function, okay, negative t squared. We use modulus, and this vector value function, okay, you can write in this form, 2 sub t and t. You can write in this form. And then the magnitude, okay, magnitude will be the square of 2. The square of 2 sub t will be 4t. The square of t will be t squared. Okay, then you sum them up in the square root. And for this one, because of modulus, negative t squared will be positive t squared. Okay, then this one you can factorize. Okay, this one you can factorize into t plus 2 squared. Okay, and we can cancel out the square with the square root, then we get t plus 2. Okay. We can now try this. Try this exercise. T square T negative sine T. ET times FT. So the ET, you multiply the ET into every single component function. Then you get an answer. Okay, any questions? Number? Number two.
After the multiply the class with the people.
This one plus this one multiply into the T. And this is 2T. So the first component is T squared. The first component is 2T. So T squared plus 2T.
Hello, plus people. Yeah, single T plus 3. One, 2T, 1, 3 cannot be plus 3.
2T with 1T. It's fine, this one? This is common. This is common. This is the, this one we can write in this form. T squared plus 2T I plus T plus 2 over T J. minus sine t plus 10k. This is the same as this. So we can't sum these two out because of this. The common means this is the component function of I. This is the component function of j. This is the component function of k. We can write the function. We can display the vector value function either this form, the one with ijk, or the one with this bracket. Okay, this one. You look at this one compared to the given question. Okay, the given question is written in ijk, but I use this bracket. They are the same. Okay, any more questions? Okay, number 3, EFT. EFT, 3T, GT. Okay, T square multiplied to G. Square. Okay. Okay, any questions? Okay, number 5, magnitude of this. This is a scalar. Okay, scalar multiplying to factor value function. So we can use this. And your ft is this one, t squared t negative sine t. We find for the magnitude of ft multiplying to the modulus of the scalar function. Okay, so modulus of -2 is 2. Then this one, you square every single component functions. T square, you get a t power of 4 plus t, the square of t is t squared. Okay, and this one, negative sine t squared. This one in the bracket square. This means -1 square, you get a positive. Sine t squared, you get a sine square t. Okay, done. The next one, we will look at dot product. Okay, dot product is used to measure the angle between two vectors. Okay, the angle between two vectors. When you have a two, okay, let's say this is F, this is G, we can find for the angle in between two vectors by using dot product. Okay. And it is also needed to calculate projections of vector. So remember this, the dot product of two vectors is scalar. Okay, the output is a scalar. When A vector A dot vector B, the output is not a vector, it is a scalar. Okay, so hence it is also known as scalar product. Okay, scalar product. So A dot B, A is A1, A2, A3, B is B1, B2, B3. So when we A dot B, okay, A dot B, that means A1 times B1 plus A2 times B2 plus A3 times B3. This is dot product. Okay. So if your dot product equals to 0 value, it means A and B are orthogonal. Orthogonal means 90 degrees, perpendicular. Okay, when the dot product is 0, meaning that two vectors are perpendicular. We call it as orthogonal. Okay, these are some properties of the dot product of vector valued functions. So let's say A, B, C are vectors and K is a scalar. So A dot B is the same with B dot A. Okay, it satisfies the commutative property. And this one, A dot B plus C dot is multiplication. Okay, multiplication. This one means this means A dot B plus A dot C. Okay, you distribute A into this. Okay, distributive property. Okay, no matter it is from the left or from the right. Okay, so this is A dot C plus B dot C. Okay, it satisfies the distributive property. And it also satisfies the associative property. Okay, associative property. Okay, this one K is a scalar. Scalar multiply into this is dot product. So K is either multiplied to A or B, because this is multiplication. Okay, multiplication multiply K. So K either multiply to A or multiply to B only. Okay. This is a zero vector. Zero vectors. That means 0i plus 0j plus 0k. So when a vector multiply to a zero vector, you will get 0. Okay, any vector multiply to zero vector, you will get 0. Okay, when a vector A multiply to the vector itself, you will get the magnitude square. Okay, magnitude square. Because this one, when you multiply, okay, dot product, you get a scalar. Okay, scalar. This is A squared. So A dot B, okay, if A and B are different, that means A dot B will be this one. Magnitude of A times magnitude of B times cos theta. So from here, we can find the angle in between two vectors by using this formula. Okay, when we have two vectors, we are able to find for the angle in between the two vectors by using this formula. Okay, this is the first example. Find the dot product. Okay, so that means sine t times cos t plus cos t times sine t plus ln t times t. Okay, you get this line. And we can combine these two. Okay, these are the same thing. Sine t cos t and cos t sine t, they are the same. So we have 2 sine t cos t. Okay, plus the t ln t. Okay, dot product is very simple. As long as you remember, okay, remember how to compute for the dot product, because the formula is not given. Okay, formula is not given. Okay, given vectors f F and G. Find the value of K, this one, K, if these two vectors are perpendicular. Okay, so you have to know that when two vectors are perpendicular, it means the dot product equals to 0. Okay, dot product equals to 0. So F dot G equals to 0. So on the left, you carry out the dot product, this one times this, okay, plus this one times this, plus this times this. Okay, get this on the left, and then you just solve for the K. Okay, solve for the K. This one you have 5 ET. This one you have minus K ET. You factorize the ET, so you have negative K plus 5. Okay, negative K plus 5. That means 5 minus K. They are the same. And ET, it will never be 0. No matter what is the value of t, exponential, you will never get 0. So 5 minus k equals to 0. Okay, and k is 5. Okay. Okay. Exercise 8.2. Find the dot product. Find the dot product. That's mean F dot G. F dot G. Okay, so this means -1 times -8 plus 9 times -3 plus -3 times 4. Okay, the first multiply to the first plus, the second multiply to the second plus, the third multiply to the third. Okay, so this one total of -31. Okay, F is E squared sin t cos t. GT is ET sin t cos t. We haven't signed for attendance. Okay, T square ET. Write it down here. Okay, T square times ET. T square ET. No more bracket because this is no longer factor. T square ET and plus sine square T plus cos square T. And sine square T plus cos square T is 1. It is an identity. Okay, number 2, A and B are orthogonal. Okay. A and B are orthogonal, meaning that A dot B is 0. A dot B is 0. Oh, I'm sorry. I want you to show. Want you to show. So you have to do this. A dot B equals to 0. Okay. When we want to show, means that you have to find. You have to find until you get 0. Okay. If you start from the equals to 0 just now, that means we have confirmed that A dot B is 0. Okay. But now you are asked to show that A and B are orthogonal. That means A dot B equals to 0. Okay. This is how we show. Unless you are given A and B are orthogonal, to find an unknown in the vector, then you have to start with A dot B equals to 0. Because that is given. Given means they are confirmed orthogonal. Okay, next we look at the cross product. Okay, another product. Okay, cross product. The cross product, you can either use the way just now we find for 3x3 matrix, or you can use this. Okay, actually we get the same answer. So this way is you list down the vector of A, this one, vector of A cross vector of B, and to get this, okay, to get the component function of I, you just cover the first row. Okay, cover the first row, and then here you use AD minus BC to get this. Okay, and for the component function of J, you cover the second row, second row, cover the second row, and then AD minus BC to get this. And for the component function of K, you cover the last row, you apply the AD minus BC. Okay, but if you use this way, make sure you put a negative for the second component. Okay, the second component, you have to remember to put a negative. If you use this way to get the cross product. Okay, and note that A cross B is orthogonal to A and B. What does this mean? A cross B is orthogonal to A and B. What is A cross B? A cross B is a vector. A cross B is a vector. And the vector is orthogonal to A and B. And when you have, let's say, two vectors, okay, vector A cross vector B, you get a vector. Okay, this is A cross B, A cross B, A cross B. This one should be A, this one should be B. Okay, A cross B, this is A cross B. And this A cross B is perpendicular to B and also perpendicular to A. Okay, this is what it means. So it means if you have this is A, this is B, vector A and vector B, the A cross B will be perpendicular to both of these A and B. Okay, that is A cross B. Okay, that's why when you look at this sentence, A cross B is orthogonal to both A and B. Okay, next one, we look at the properties of the cross product. Okay, let's say A, B, C are vectors and K is a scalar. So A cross B is not the same with B cross A. When you swap the order, you have a minus. Okay, and then it satisfies the distributive property. So A cross B plus C, it means A cross B plus A cross C. This is similar to the dot product. Okay, no matter this is comes from left or right. Okay, this is A cross C plus B cross C. Okay, distributive properties. Okay, next one, associative property. Okay, since this is multiplication, so your K is either multiplied to A only or to B. Okay, it's either to A or B only. Okay, A cross zero vector, you will get zero vector. Okay, because the output from cross product is a vector. This is a zero vector. And when A cross to the same vector, you will get zero vector as well. Okay, and for the cross product, okay, magnitude of cross product is same as this. Okay, now we look at the first example. Find the cross product of these two, okay, F and G. Okay, so this one you can either use this way or use this way. Okay, this one you use 3 in a group, 3 in a group, and 3 in a group minus the other direction, you will get this. Or you use this F, this is your F, and this is your G. So cover the first line, AD minus BC, you get this. And then cover the second line, AD minus BC, you get this. And cover the last line, AD minus BC, you get this. But remember, for the component function of J, you have to put negative here. Okay, if you use this. Which one do you prefer? The first one or the second one? Second. If you use the second one, it means that if you list out, okay, you list out one by one. Okay, you list out one by one. Okay, so same goes to this one. Okay, actually they are the same. You just apply the way to find a 3 by 3 matrix. You will get this. Okay, you will get this. You can try this exercise for the cross product. Find the cross product of F and G. F cross G. So if you want to use the 3 by 3, you want to use this one, right?
Yeah.
Okay. So you let's start one by one. Okay, let's draw 9 times 4. Okay, 9 times 4. So you have 36 9. Okay, 1, 2, 3 plus 1, 2, 3. Okay, this 1, 2, 3. 1, 2, 3. So you get a plus 3 for J. That's 1, 2, 3. But 3K. This one minus the other direction. Okay, dot product and cross product will be used in your engineering subject, so make sure you know how to compute for dot product and cross product. Okay, so the other direction will ever be negative 72 K. And this 1, 2, 3 will be plus 9 I. And this 1, 2, 3 will be minus 4 J. So I combined with I. 36 minus 9. Okay. So 25 I. Okay. 27. Then J with J. So this is plus. So 24 plus 4. And K with K plus 75 K. So either you give your answer in this form IJK or the one with bracket. Okay. Number 2. I use different color. Okay, number 2 and one number B. Number B. D square sine t cos t. Okay. Cross product will be I, J, K. F first. F first. Okay, this one. Sine t cos t. This one plus b cos t. This one plus t square sine t. Okay, minus the other direction, et sine t. Sine t k. Sine 3 cos t I. And t square cos t j. Okay, so I with I. So sin t cos ti minus sin t cos ti et cos t j. This one, et cos t minus e square cos t j. And k with k, e square sin t minus et sin t. Okay. Okay, so this one you can factorize cos t, this one factorize the sin t. Okay, this one, if you write in the form of bracket, okay, if you write this in the form of bracket, there's no component of I. Okay, there's no component of I, so you have to put a 0 for I. Okay, then followed by this one, et cos t minus t squared cos t, comma, t squared sin t minus et sin t. Okay, so if you want to use bracket, even though the component function is 0, you have to put 0. You cannot leave it. You cannot leave it and just show the other two. Okay, because this is a three-dimensional vector value function. Okay, number C. Okay, this one, yeah. Plus, this is not a bracket. This is not a bracket. This is determinant. Two straight lines, determinant, not bracket. Okay, this is actually a determinant of 3 by 3 matrix. So you can use whatever you have learned to find the answer. Okay, 3 by 3 matrix determinant. What I use is the shortcut that I introduced in the class. 3 in a group. Okay, 3 in a group, and these two combine like this. Then the other direction, 3 in a group, 1, 2, 3, and 1, 2, 3. Okay, question number 2. Given A and B, find the vector which is perpendicular to A and B. That's it, A cross B. Okay, you have to find for A cross B. Okay, any questions? Okay, next one, differentiation of vector value functions. Okay, when we want to differentiate vector value function, actually, this is same as how we differentiate a function. Okay, we just differentiate the component function separately. Then we get the derivative of the vector value function. Okay, very straightforward. Okay, and note that R prime. Okay, this one R prime is a tangent vector at the point corresponding to RT. When you have a, let's say this is your RT, when you have an RT, okay, and at a specific point, you have a R prime T. Okay, this is your tangent vector. R prime is your tangent vector. Okay. Okay, compute the derivative of this. So you just differentiate this one. 2 cos t, you get -2 sin t. Differentiate 4 sin t, you get 4 cos t. Differentiate 5t, you get 5. Okay, very straightforward. The differentiation of vector value function. Okay, now compute the acceleration given the path. Okay, this is a path. So to get the acceleration, you need to differentiate twice. Because after you differentiate for one time, you get velocity. Okay, and one more time, you will get acceleration. Okay, so differentiation is in log t. When you differentiate, you get 1 over t. T cubed, you get 3t squared. This one, differentiate this one, you get 5 plus et. Okay, this is your velocity function. And differentiate this once again, you get acceleration. Okay, so 1 over t, when you differentiate, you can write this as t to the power of -1. Okay, t to the power of -1. T to the power of -1. So when you differentiate, so -1 you bring to the front, -1. And t to the power of this one minus 1 more, you get -2. Okay, so you get a -1 over t squared. Okay, this one. And differentiate this, you get 6t. And differentiate this one, you get et. Okay. Now compute the speed. Okay, given the path, compute the speed. The speed referring to the magnitude. Okay, the magnitude, this means speed. The magnitude of this, okay, you square the 1, square the sub2t, square the t squared, okay, and sum them up in the square root. Okay, so here you have 1 plus, okay, sub2 squared, you get a 2. T squared, you get a t squared. Okay, and this one, t to the power 4. So this one, we can factorize. Okay, we can factorize. Okay, how to factorize? You have t to the power 4 plus 2t squared plus 1. Okay, I'm sure all of you have learned how to manually factorize the function. Okay, so this one, we can break it into t squared. T squared times t squared, you get a t to the power 4. And then 1, we have 1 times 1, we get a positive 1. Okay, positive. This is positive, that means either plus or minus. Okay, since this is the plus, that means this is plus. So t squared times plus 1, you get a t squared. T squared times plus 1, you get a t squared. When you total up, you get a 2t squared, which is this one, plus 2t squared. So this one we can factorize as t squared plus 1 times t squared plus 1. Do you learn this? Did you learn this before? Yes. I'm sure you have learned this. Even though you use your calculator to do the factorization, unless your teacher never teach this. This is important. This one, we can't use calculator to get the answer. You have to do it manually. Just like when you have x squared plus 2x plus 1. When we factorize x times x, you get an x squared, 1, 1, 1. plus. Okay, that's mean here either plus or minus because -1 times -1 you get +1. +1 times +1 you still get +1. So either plus or minus we look at here. This is plus, that's why it was plus because here you get x, here you get x, when you somehow you get 2x. Okay, so this is factorization. Okay, now back to this. Example. We can cancel out the square root with the square. So that's why you have only 1 plus t squared for the answer. Okay. Okay, exercise again. Compute the derivative of the following position factor value function. We just want the derivative, the first order derivative. Okay. And number 2, you need to compute the velocity, the speed, acceleration. Velocity means f prime. Acceleration means f double prime. The speed means magnitude of f. Okay, magnitude of f. The magnitude of f. Speed is the magnitude of f. Okay, we try to solve number 1. Okay, solve number 1. Number 1A. Okay, FT is P2T, 4ET, and EET. Okay, for question number 1, we just compute for f prime. Okay, this one you need product rule. Okay. Or d for d, we can write the square root as power of half. And the 1/t² is t to the power of -2. Okay. Can we not see? Okay, for number 2, you need to find for velocity, acceleration, and also the speed. Okay, the speed is the magnitude. Okay, velocity and acceleration can be quite simple. Okay, this is a two-dimensional vector. Okay, two-dimensional vector. Okay, differentiate, you get 3 and 2. Right? 3 and 2. When you differentiate once again, you get 0, 0. And for the speed, okay, you have to compute the square of this. Speed. Speed. Okay, I think the speed is the magnitude of f prime. The speed should be the magnitude of f prime. I think this is the prime force. Compute the speed of the given path. Okay, this one should be given velocity. Okay, this one should be given velocity. Okay, because the speed and speed from velocity, this one should be prime. Okay, this one should be prime. The speed is the magnitude of velocity. Okay, so 3 squared and 2 squared get a 13. So 13. So I repeat, once again, for this example, this one should be velocity. Compute the speed of the given velocity. So this one should be prime. F should be F because this is velocity. Sorry, I forgot to share this one. Okay, this one, the spine of this example. Okay, for those who join online class, okay, the spine of this example, this one should be velocity, not path. Okay, not path. This is a velocity, so the speed of this velocity is the magnitude of this velocity. Speed is the magnitude of velocity. Okay, so change this into velocity, from path into velocity. So here, the speed is the magnitude of velocity. Okay, speed is the magnitude of velocity. Okay, so that's why this is, we are taking from the velocity, and then we compute for the magnitude of this velocity to get the speed. Okay, the rest of the question we will continue in the next class. Okay. Yes, next year. So this Thursday and Friday, we do not have class. For this EM1, okay, I only for this Thursday and Friday. Okay, so see you next year, next Tuesday. Yeah, next year.